Okay, this is Mr. Peterson, and I'm on the 8.5 notes for Algebra 2, and this is page 2. And on this page, I'm going to introduce you to a new way of solving using your graphing calculator. So first, the concept. If you have an equation and you treat the left side and the right side as graphs, so you go to your y equals key, and on the first line you graph the left-hand side. There's the left-hand side. And you graph on the second line the right-hand side. Then what you have is an equation for y here and an equation for a different y here. But if these graphs cross each other, so you find the intersection, at that point the y value is the same for both graphs. It's the same height at that point. And if that's true, what happens is this y and this y at that point would equal each other, and you would have this equal to the y1 and the y1 equal to the y2 and the y2 equal to the other expression. And the idea is they're all equal to each other, so eventually this 5x minus 2 would be the same as 2x plus 13. So in the end, sides of the equation and find out where they intersect or where they cross, and you'll have your answer. So my first example here, I'm simply going to go to my y equals key and type in the left-hand side. Drop down a line and type in the other side, and we've got two graphs. This one will be a curved graph, and this will be a horizontal line. And where those two lines meet, that'll be the x value we're looking for to solve this. Now we're going to go ahead and say zoom 6 on this. So we did this on the y equals line, and now we're going to say zoom 6 here, which is the standard graph. So you'll see this graph show up here, zoom 6. And here it comes. Here's the first equation, and that represents the left-hand side of the original equation, and that y equals 7 shooting across there represents the other side. Now you can probably tell that they're going to meet somewhere off screen over on this side, and because this one looks like it's rising up there to meet it. So what we're going to have to do here is adjust the window to open up the right side of the screen. So go down here to the x max, and let's just double it to 20 and see what that does. Touch graph. If you can see the intersection, you're set up for finding it. There we go. Whatever x value is at this location over here is going to be our answer. So the steps to find that intersection are second, calc, 5 is intersect, and then you're going to hit, you're going to scroll and hit enter 3 times. I'll explain that as I do it. Okay, so second, calculate, you'll find it above the trace key. You want the 5th choice, you can just type 5 to do it faster than I'm showing it here. And it's going to ask for first curve, and it's already blinking on the first curve, so hit enter. And then it says second curve, and you learn out pretty quick that even though it's a line, it's calling it a curve. And then scroll over before you hit enter, and it's going to want to ask a guess, and if you're close to the answer, just hit enter when it says guess, and it'll go right to the intersection and tell you what it is. So here's the answer. X is 12.7241. So the sequence goes like this. Second, calc, choice 5, scroll next to it, and hit enter 3 times. And you're there. Okay, we'll do that with 2 more examples here. And this next one has a little bit of an exception. All right, so I've got the equation on the left and just a -4 on the right, so I'm going to type those in. On my y equals line, 6 raised to negative 0.23x. That's the left side, and the other side is -4. So I'm going to start with zoom 6. And you can see this thing diving down like this, and it's staying above the x-axis because that x-axis is its asymptote. Then you have another line that comes through here, and if anything, this is probably not going to touch. In fact, it won't. This thing is staying above the x-axis. That's a horizontal asymptote. But let's take the window and expand it over to the right. Let's go out to 100 and see if that helps us find an intersection. When we hit graph, the right-hand side is way over, and you can see that they still don't meet. There we go. They still don't meet. In fact, they don't meet, and since there's no intersection here, we know there's no solution here. Now, backing up to this one, you can label that x-axis the horizontal asymptote. Y equals 0 is its equation, and that graph stays above the x-axis for its whole trip. It just gets closer and closer to it. Okay, this next one's a practical example of how to apply some of this. Brazil is the 5th most populous nation, and the ones ahead of it are China, India, the US, and Indonesia. According to a census taken in Brazil in 2013, there were 201 million people there. So you can see I put my A0 as 201, and that represents million. Now, it tells us in the problem the population is growing at 0.9% per year. So let's find our base. It's going to be 100% increasing by 0.9%, which if you carefully do this is 100.9%, and slide your decimal back 2 spots to find the decimal version of that number, and that's your base. So we want to know how long it will take. I put a t up there for my variable, for that 201 million to grow to 250 million. And we're ready to go here. We're going to set up the left side at 250 million. And the right side has a 201 million with a growth factor of 0.9%, and we're going to have to use x instead of t, but we've got it set up here. Now you have to think about this for a minute here. This is a horizontal line way up at 250. So we want a y max that's higher than that. And so I'm going to go down here and go 350. And I don't think it's going to take 100 years to do this, so I'll try 20 to start with. Touch graph. I have different numbers here, but I think this will be fine. And I think I'm wrong. It's not going to barely missed over here, okay? So I do have to extend that. I'm going to extend that window to 30 years out and see if that's enough. Once you see the intersection, then you're ready to find it. Yeah, that crosses there. Right about there. Okay, second calc, choice 5. Move your cursor next to it. It always finds the closest one, so if you want to find that one, get over close to it. Hit enter 3 times. And you'll get 24.3485. So if we add to that the initial year of 2013, let me do that. 24.3485, I don't need all that accuracy, but plus 2013 is early 2037. If this had been 0.8 or 0.9, I'd say late 2037. If it says 0.5, 6, or 7, I'd say mid. Okay, so there we go. That's page 2 for the 8.5 notes in Algebra 2.